Hello. Well, in this video, we will talk about complex numbers in trigonometric form. uh, Trigonometric form. But before starting with this trigonometric form of complex number, I want to introduce another notion, the notion of a complex conjugate of a complex number z given in Cartesian form. Well, this is a very important notion and we will use so many times, so it is important to fix this notion of a complex number. Okay, if I am given, suppose that I am given a complex number z in Cartesian form, so let us say x plus jy. Well, the conjugate of z, which is the number, it is denoted by z star, simply given by x minus jy. So, for example, if z is 3 plus j2, well, the complex conjugate is given by 3 minus j2. It's very simple. It's simply obtained by changing the sign of the imaginary part. And it is straightforward also to see their representation on a complex plane, because if this is z, this is the real part of z, while this is the imaginary part of z. Well, the z star, the conjugate, has the same real part but have an imaginary part that is the opposite of this. So we will find that the vector representing z star is simply obtained by flipping z over the real axis. So this is okay. So we have introduced this complex conjugate. So now we can start introducing the trigonometric form of complex numbers. So let us given x as x plus jy. Yeah, we know that on the complex plane, this is represented by a vector that has a real part and an imaginary part. That's good. But we have also introduced last time the concept of modulus of z. We used it last time. We used this symbol to indicate the length of this vector, but now we will also use another symbol, which is this Greek letter rho, to denote the length, okay, the length of this vector. And we have also introduced the notion of the argument of theta, which is the angle the vector z is inclined over the real axis. Now, some basic trigonometry tells us that x, which is the real part of z, is simply given by rho times the cosine of theta, while y is simply given by rho the sine of theta. Now, if we replace these two expressions in the Cartesian form, what do we get? Here is simply that, I would say z is given by rho times the cosine of theta. This is simply x plus j. I have to replace here y, but y is rho times the sine of theta. And if we gather the common factor rho, what we got here is this expression, rho times the cosine of theta plus j the sine of theta. Well, this is what we call the trigonometric form of a complex number. This is very important. This is the trigonometric form of a complex number. Now, if we take a look, we have just used the notion of modulus and argument to represent the complex number in a different form. Now, if we take a look at this form, we see that Now it is very, very easy and it is straightforward to find in a complex number given in this form the modulus rho and the argument theta. While in the other form, in the Cartesian form, we remember that we had to do some calculations to find the modulus and the argument of the complex number. While in this case, on the other hand, we must do some calculation to find the real part of z, because the real part of z in this case is given by rho times the cosine of theta, and the imaginary part of z is given by rho times the sine of theta. So every form has its own pros and cons. In this form, we see quite soon what is the modulus and the argument, while in the other we find easily the real part and the imaginary part. Now, if we apply the definition of a conjugate of a number to this representation, well, it is very straightforward to see that z star, we know that z star can be obtained by changing the sign of the imaginary part. So we have that rho is the cosine of theta minus j the sine of theta. And this is equal to rho. Well, just remember some basic trigonometry. The cosine of theta is equal to the cosine of minus theta. And minus sine of theta is simply given by the sine of minus theta. Well, this is something very interesting because this tells us that the conjugate is a vector of a given number z is a vector with the same modulus but with an argument which is the opposite of the previous one. So in this case, simply this vector has the same modulus. This is z star, okay, which has the same modulus and has an argument which is the opposite of the given complex number. Now let's do some practice with an example. Okay, let's make an example just to fix the new ideas that we have found. Let us consider the number z given in trigonometric form as 5 times the cosine of 4 pi over 3 plus j the sine of 4 pi over 3. Okay, now if we want to represent this on the Cartesian plane, what we soon observe is that the modulus of this complex number is 5. So this complex number has to be located on a circumference with a radius 5. And the argument is 4 pi over 3. So if this is 4 pi over 3, this is this is pi over 3, this is 2 pi over 3, 3 pi over 3, well, this is 4 pi over 3. This angle is 4 pi over 3. This means that this is the representation of z. Well, as you may see, we did very little work to find the location of z on the complex plane in this using this representation, because it soon showed us, it was soon clear what is the modulus 5 and what is the argument. Some work has to be done if we want to find the real part of z. Well, the real part of z, we know that it can be found as 5 times the cosine of 4 pi over 3, while the imaginary part of z can be found by multiplying 5 the sine 4 pi over 3. And, well, this means 4 pi over 3, the cosine of 4 pi over 3 is simply minus the cosine of pi over 3. So this is 5 times minus 1 over 2, which is minus 5 over 2, and this is 5 times minus square root of 3 over 2. And this means minus 5 times square root of 3 over 2. So if we want to express this complex number z in Cartesian form, now we can do, because z can be written as minus 5 over 2, this is the real part, minus 5 times square root of 3 over 2j. And now it is also straightforward to write z, the conjugate of z, by changing the sign of the imaginary part. So z star is given by minus 5 over 2 plus 5 times square root of 3 over 2j, which has to be equal to what? Well, remember what we have said before just a few minutes ago, and we know that z star can be expressed by changing the sign of the argument. So in this case, this has to be 5 times the cosine of minus 4 pi over 3 plus j, the sine of minus 4 pi over 3. Okay, this is all for this lesson. Next time, in the next video, we will start talking about the exponential form of a complex number. Thank you.